Hello. Welcome to Physics-1 by Santanu. So today we will continue the dimension analysis from AC Verma's book. We will cover in this video problem number 2 to 3, 4 and 5. So let's check problem number 2. Here first they say to find the dimensions of the angular speed omega. So omega is the rate of change of the angle theta with respect to time t. So and they also ask for the dimensions of angular acceleration alpha, which is rate of change of omega with respect to time, torque tau, which is f dot r, and a moment of inertia I, which is mr square. To solve now, we can move on the solutions. So angular speed omega is equal to change of theta by change of time. Now theta is dimensionless because it represents angle, and delta t is basically the time gap. So its dimension would be 1 over t or t to the power minus 1. In terms of the main three base quantities, that is mass, length and time, it can be written as m to the power 0, l to the power 0, t to the power minus 1. So it is the answer. Now we can go to the angular acceleration part, which is alpha is equal to rate of change of omega with respect to time. Now we have already found omega's dimension, which is m0 l0 to the power minus 1, and time's dimension is t. So it becomes m0 l0 to the power minus 1 over t. T from denominator goes to numerator and it becomes m0 l0 t to the power minus 2, which is the dimension of angular acceleration. Now coming back to the dimension of torque tau, f dot r. F is force and r's dimension is the dimension of length. Now force, the dimension of force is ml t to the power minus 2. With it we know that the length is r and its dimension is l. So together we get ml2 to the power minus 2. And last, at number d, it is moment of inertia I is equal to mr square. So m is mass, so its corresponding symbol is capital M, and r is length, so corresponding dimension would be L square. So in terms of basic two quantities, we get ml2 t to the power 0. So it is the answer for moment of inertia. Now we move on to the third question, that is to find the dimensions of electric field E, magnetic field B, magnetic permeability mu 0. This is the three questions, and we know the corresponding formulas written here. It is E, it is B, and it is mu 0. Now here F is force, Q is charge, V is speed, I is current, and and the distance is denoted by A. Now the first question is to find the dimension of electric field. Now we know F is equal to QE, so E is equal to F over Q. Now the dimension of F is ml t to the power minus 2, and there are now we have to find the dimension of Q. Actually, the fundamental or base quantities are the number of fundamental quantities are 7, which are length, mass, time, electric current, the thermodynamic temperature, amount of substance, and luminous intensity. Now here current I can be written as Q by T. So Q is equal to IT, So we write q is equal to it, and f is in the numerator ml t to the power minus 2. Now if we rearrange it, it gives us the answer ml t to the power minus 3 I to the power minus 1. So it is our answer for electric field. Now for magnetic field, f is equal to qvv, so b is equal to f over qv. Here v is speed. Now we have already know the dimension of f, q and v, and putting them in this equation we get finally ml to the power 0 t to the power minus 2 I to the power minus 1. Now what about mu 0? Now from this equation b is equal to mu 0 I over 2 pi a, we get mu 0 is equal to b into 2 pi a by I. Now 2 pi is a number, so it can if we can find the dimension of ba over I, that will be the dimension of mu 0. So mu 0 would be, first we write the dimension of b, ml 0 to the power minus 2 I to the power minus 1 into l, a is the distance, so it is length basically, divided by, in the denominator here is I. So rearranging it, we get ml t to the power minus 2 I to the power minus 2. So it is the dimension of magnetic permeability mu 0. Now let's move on to question number 4. Here they ask to find the dimensions of electric dipole moment P, which is q into d. Q is charge, d is distance, and magnetic dipole moment M. M is equal to I into A, I is current, and A is area. So for electric dipole moment, P is equal to QD. Now Q is equal to IT and D is distance, so it is L. Rearranging it, we get M to the power 0 LTI. It is the dimension of electric dipole moment. And for magnetic dipole moment, M is equal to IA. I is the current, so it's current's dimension is I, and A is area, which is length square, so basically it's L square. And rearranging it, we finally get m0 L to the power 2 t to the power 0 I. Now let's move on to question number 5. Find the dimension of Planck's constant h from the equation E is equal to h nu, where E is energy and nu is frequency. Now it is given that E is equal to h nu, so we can write h is equal to E over nu. Now we know the energy's dimension is ml2 t to the power minus 2. Like you can derive it from E is equal to mc square. M is m's dimension, mass dimension is m, and c square is L2 to the power minus 2. So energy's dimension is ml2 to the power minus 2 divided by nu. Nu is frequency, so it is the inverse of time, t to the power minus 1. So in denominator, here we place t to the power minus 1. So when it goes to the numerator, and after rearranging, we get ml2 t to the power minus 1. So friends, that's all for today. If you like this video, kindly share and subscribe to this channel for more such videos.